Good morning, everyone. Welcome back. We're here in the session on safe and ethical priorities for AI. And I'm really excited that we have a wonderful set of speakers. We have Tabitha Goldstaub, Professor Joanna Bryson, and Professor Nathan Lepora. The format is going to be that Tabitha has kindly agreed to have a fireside chat with me for a little bit, and then Joanna will give a talk, then Nathan will give a talk and a demo, and then we'll have Q&A with happily everybody, but primarily for Joanna and Nathan. And we were really excited to see in the previous session that Tabitha chaired so well, there were a lot of interesting questions that came up focused on the topics of this session. So we've brought two of those already into the Slido Q&A. And if you have more questions, please do post them into Slido and you can upvote whichever ones you find most interesting. So without further ado, we are going to start our chat with Tabitha. Tabitha has had an amazing, inspiring trajectory, which has landed her right at the center of all things AI in the UK. Tabitha is director of the very popular CogX Festival of AI that many of you have likely attended. And of course, she's the chair of the AI Council. Thanks so much, Tabitha, for your very able chairing of the last session. Now we'll have a bit of a chance to hear your views.
It was an honor.
Great. To get us into our theme, I'd like to start with a quote from your council AI roadmap. So I'm just taking part of it here. I'm sure this will sound familiar. So part of this says that it's really key that we stay at the forefront of the development of AI and integrating approaches to ethics, security, and social impacts and planning for the next 10 to 50 years. The UK will only feel the full benefits of AI if all parts of society have full confidence in the science and the technologies, and in the governance and regulation that enable them. That confidence will depend on the existence of systems that ensure full accountability, clear ethics, and transparency. So that's what we're going to focus on. And I'd also just want to mention that it really fits in well with the three main themes that Oliver Dowden highlighted as key aspects of what is likely to become the evolving AI strategy. So he said that the new AI strategy will focus on 1, growth of the economy, 2, ethical, safe, and trustworthy development of responsible AI. So that's what we're talking about now. And 3, resilience in the face of change through an emphasis on skills, talents, and R&D, which we'll also have a chance to touch on. So coming back to our theme, we're going to talk about why ethical, safe, and trustworthy deployment is so important and what we should focus on. But I think perhaps we can start with an area that I know is very close to your heart and was raised loud and clear in your previous session. That is diversity and skills. How can we ensure that all voices are not only heard, but actively engaged in the design, development, and deployment of AI systems? Tabitha.
Gosh, well, you have framed the challenge well, and I'm really glad that we get to have this conversation, because what I always feel like is that there's never enough time when you go through the roadmap to dig into all of the different areas, and as you point out, for me, there is no AI unless it's safe and ethical. So for anyone who was thinking, we didn't touch on that properly in the first session, I think in my DNA, in its DNA, as you heard from Adrian Smith, the director of Turing, it in itself is now no longer able to have AI without it being safe and ethical. Is really what we should be talking about. Anything that isn't should almost not be considered in this space anymore.
Fantastic. So if I may, I'll suggest that we will soon get into questions about what exactly is safe and ethical AI and what should we really focus on. But I do want to give you specifically the chance to talk about your passion for skills and diversity. I'm gonna give a plug to your book because Tabitha actually took some time to write this excellent book, How to Talk to Robots: A Girl's Guide to a Future Dominated by AI. I'll give her a chance. Oops, I hope you can see it. There we go.
Maybe you can see my copy.
Very good, very good. And I also want to show that I'm delighted that I have one of a limited number of copies that are signed by Tabitha. Oh dear, it's not coming out, but it really
it is signed.
And if you want one like that, then Tabitha has kindly said that if you go to dauntbooks.co.uk, we'll post the link, and she's going to kindly make some more signed copies available. Perhaps you could tell us, why did you write that book? Who's it for? And what's it going to achieve?
So you asked the question around how do we make sure that the people who are building the AI systems and really at the center of sort of the research community and the industry are diverse. And that, I think, there is a huge amount of work to do, and we can come to that. I know that later today there's a session that Dame Wendy Hall is chairing on exactly this topic. She's the skills champion for the AI Council, and we suggest a few different areas in the roadmap, which I'd love to talk about. But your second question about where I wrote the book is actually a very different audience. So what my concern has been is that the people who are not being engaged at all in technology, let alone artificial intelligence, are really being left behind in this conversation. And as you heard in the previous session, all of the panelists, Adrian, Fernando, Jenny Tennyson, really made incredibly clear how we won't be able to progress artificial intelligence without listening to the general public and bringing them along on the journey. But my challenge when I tried to get my friends who didn't even know what this was, is they didn't care at all. And these were bankers, they were people who worked in shops, they were my friends who were stay-at-home mums, they were lawyers. They just didn't care. And so I wrote the book to try and get them to care enough, to engage enough. And I think that in itself is it's a big challenge when so much of the media is about artificial intelligence being scary, taking jobs, killer robots. So how can we expect the general public to feel the sense that we all do around the promise of AI being able to fight the climate crisis or improve health outcomes? And so what I tried to do in the book was sort of reflect the incredible front row seat that I have onto this industry and try and get that back into the general public. And my plan for the next year is really to keep doing that in other ways, whether that's TV shows, podcasts. It's like, how do we meet the general public where they are rather than expecting them to come to us all the time, because they've got a lot on. And unless it's engaging, unless it's something that really matters, it's not going to make a difference. And so I don't think we can build safe and ethical AI. We can build safe AI without general public. We can't build ethical AI without general public, because that is so subjective as to who we're talking about. And so it needs diversity at the core.
Absolutely right. It's such an important theme, and it's wonderful that you're doing all that work to reach out, and we need to keep doing more of that. So thanks very much. And maybe we can come back to this question we touched on before. What do we really mean by safe and ethical AI? How can we really try to unpack that a little bit and figure out how to address it?
It's a real challenge, and I've been trying. When we were writing the roadmap, the AI Council is made up of some really brilliant minds, and we were trying to sort of bucket the different components. And I think we ended up splitting them into sort of 4 areas. So one is like technically being able to be safe. So technically being able to enable the user to make ethical decisions. So that's the work that I always think of you in: transparency, sustainability, privacy, robustness, and the research and development that goes around in enabling ethical decisions. Then the second bucket was around regulation. And I think we all saw from Karen Ho's recent article on Facebook how without regulation, even if things are technically possible, big corporates aren't going to focus on those unless they really have to. And that's why having adaptable regulation is key to the success of the National AI Strategy. The third area was then communications, which I really sort of laid out, I think, in the process of me talking about my book, is that if we don't explain what ethical, safe AI is, no one's going to know how to use it. And that reminds me of things like GDPR to my friends was just something annoying they had to click. No one ever realized that actually it gave them a right to an explanation or a right to be forgotten. And we're not actually even explaining in many cases what tools are at people's disposal. And then lastly, there's the whole bucket, obviously, around AI that's in the public good. And I think there's some arguments that some members of the council made really strongly, which was that should AI be created unless it's in the public good, and should AI be only for public good? And obviously, you can imagine there were some people who disagreed with that, but I think that is a debate. Those four debates is really how I frame the conversation in my mind.
Fantastic. Let me just try to recap. There are technical components of really trying to build the sorts of things we need, like transparency, privacy. Each of those is a big topic we could discuss at length. Second component is regulation. Third component is communication, which, just checking, I don't think of course, explaining to the public is super important, but also, of course, we really have to listen very carefully too.
Totally.
I know you do so well.
Communication has got to be both ways. Absolutely.
And then the part about AI in the public good. How can we use AI to achieve public goods? Excellent. And I'll give a personal view on this, which I just to check to see if you agree, which is so critical, that all of these are really carefully interlinked. We can't do sort of one piece by itself.
No, not at all, because the communication is really about public scrutiny, and I think we made this quite clear in the roadmap. There's a discussion around like a public data interest bill, and like how can we enable the public to gain enough transparency, to scrutinize enough, to then trust what is going to need to effectively be trustworthy technology, which requires the technical capabilities in order to create the trustworthy technology. So it's a house of cards. That sounds pessimistic. It's, I'm optimistic that this is solvable, but they definitely all rely on each other. And that's why I'm excited about the work that you and the Turing do in explainability, privacy, robustness, because ultimately without the fundamental research, corporations won't be able to make decisions. Governments won't be able to make decisions. I was at a session with Mariana Mazzucato's group, and they were talking about the fact that in some cases, unethical decisions are made without consciously even realizing, because the technology just isn't there to enable them to make the right decision. And so really, you and your crews need to hurry up, because there's a lot of work to be done. And earlier today, we heard Fernando talking about synthetic data, and we talk about smaller data sets, and I hear constantly all of these ideas, and we've got to get them into production so that then they can ultimately, when I say ideas, obviously I don't mean ideas, I mean research, and but we've got to find ways to get them to industry, deployed and being used.
Absolutely. So yeah, so it's a house we're all building together, and of course, in the end, we want to have proper governance, which is legally sound and technically feasible. And really appreciate your support for the effort that's needed on the technical side to get there. It's not. I mean, there are really deep, fascinating technical challenges.
It's been filtered out.
Thank you. Hope everything okay. So one thing I just want to link to before, and then we'll move over onto Joanna's talk. But just to clarify that these areas, the technical areas we're talking about, which of course need to be interwoven with listening to stakeholders and the public, engaging with governance, making sure we're working public good, but they are in themselves actually big, important challenges. And again, referring to your roadmap, you talk about ensuring that moonshots as being challenge-led, high-risk, scalable programs, which could tackle fundamental challenges such as explainable AI. So these really are big, bold challenges, which can immediately help us with safe and ethical deployment, but also will be long-term really beneficial to driving forward fundamental technology.
Well, exactly. And Joanna's a really good example of somebody who is at the forefront of this research that needs more funding, able to then unlock so much more research and then deployment, adoption, and then into the hands of the user. I think, and if we don't see that as equally important a moonshot as something that might be considered, the technology that you need to fold DNA or reduce cooling in a data center. I think this needs to be on the same level of importance, because it's not just in itself important, but it's also an enabler for everything else in order to happen. And I think we saw that in the first wave of the web. Tim Berners-Lee himself says he wished that there was more regulation in place, more technology in place that would enable a safer environment. And we get the chance in the AI community. I believe that the AI research community has the chance in order to build progressively together, rather than racing ahead in one way and then waiting for the safety research to catch up. And I think that we've seen from the amazing work that's happening with just being at the AI conferences, that the concerns that might have been happening 2 or 3 years ago is definitely being assuaged, but we need to make sure that the funding comes with it. It can't just be a grassroots initiatives.
Absolutely, thank you. We hope that our friends at EPSRC, UKRI, and other places are listening loud and clear.
They hear me a lot on this.
Thank you so much, Tabitha, and thanks so much for agreeing to stay with us throughout the session. So Tabitha will be around for our Q&A right at the very end.
Yeah, I wouldn't miss Joanna and Nathan. I need to learn. I've already seen some of their slides. They're awesome.
Fantastic. So that leads us wonderfully into our next speaker. Delighted to have with us Professor Joanna Bryson, Professor of Ethics and Technology at the Hertie School of Governance in Berlin. Over to you, Joanna.
Okay, great. So are you hearing me? Yeah. Okay, right, great. Okay, so we're on the slides, right? I was looking for my picture. I'm sorry, new to the happen. Okay, so is safety an option? I'm actually, unusually for a 15-minute talk, going to, oops, there we go. I actually have an outline. So I'm going to talk about safety. Where does the mandate for AI safety come from? That we're already there. Basically, we do have that mandate. And then I'm going to talk about how safety is like bias, which might be surprising to you. And then I'm going to talk about ensuring prosociality. So that quote that Adrian pulled from Tabitha's book was perfect. Okay, so safety is an AI mandate. I hope that everybody knows that we have 5 principles that not only the OECD, but also the G20, including China, signed up to. And of those, one of them is the 4th one, is that we build AI in a secure and safe way. So it's an obligation that is the same as the other obligations we have with respect to any manufactured commercial product. Okay, so that was already something we've all signed up to and agreed to. Where did that come from? It actually came from the British. There's an incredible commonality between, not perfect, and there was some really great innovations done by the OECD group, but now here you see that same sort of requirement in the 3rd position, and that actually derives from the 3rd Asimov's law. So this was something that our own Lillian Edwards recasted the Asimov's laws into the idea of the robot itself being the center. Okay. So yeah, and then we added in, this was the again, EPSRC and AHRC Safe Robots meeting in 2010. And we decided between ourselves, between the experts that they brought in, that this would be our primary output. And so you can see, yeah, safety. Unlike the OECD principles don't mention the military aspect, which is the one difference. They made human-centered principle number 1. So that was another difference. But anyway, safety, right in the core. Okay, so safety is a mandate. Product safety is already established in the law. AI is a feature of commercial products. It's not like a thing in itself. You don't just go buy AI, right? AI is just another feature of commercial products. And that's true even when those products are purely digital and deliver services. So for example, web search or social media. I'm sorry? So, okay. So it would be helpful if the EU or the UK, I don't know exactly where you guys are legally about this, but I know that the EU, what I just asserted is still ambiguous in the law. So it would be useful if we did that here too. Okay. So how safety is like bias. You weren't expecting this one, right? I actually gave, this is the most recent time I gave an AI safety talk was in 2002. And this is my postdoc. I was working on explaining why it was that not just monkeys, but also children, if they see an apparatus like this, where some food has been dropped in that thing above the tube, they don't look at the end of the tube. They look underneath they look underneath where the food was dropped. Now, if you give this on a horizontal table, then they'll get it immediately. They understand the tube matters. But children and monkeys cannot get the idea that it's not going to fall straight down. Gravity is more important to them than this weird tube thing, okay? So I actually put that into so there's the original publication. And I was working with Mark Hauser, one of the professors on that paper, on understanding how we could capture this apparent ignorance to actually ensure safety in AI. All right, so what this is called is a bias, right? It's the gravity bias. And it seems to be, it seems like it might even be instinctive, or else it's something that you experience very soon as a young child. All right, so why do we have biases? It's because it takes time to think. Intelligence is a kind of computation. It's a physical process. It takes time, energy, and space. And that kind of time can just explode. I don't want to take a lot of time here, speaking of time exploding, but the point is that even if you're trying to understand a relatively simple kind of problem like chess, you can rapidly result in a situation where knowing the whole answer would take longer than the universe is old, okay? So that's not what we do. What we do instead is we do something called concurrency, which is that we all work together. There's 8 billion of us, we have similar problems, and we can work on them, right? So that saves us time, but as you might have noticed, it doesn't save us space or energy. So we still have to have a lot of people working concurrently. Quantum is a similar kind of approach. It's coming in the future. We will have more AI, but we're still not going to have unlimited, infinite AI, right? It's something that takes even more energy. And so people are saying now that it's unlikely to be used by things other than, for example, nation states for security at large scale. So the point is, this is my quantum expert. The point is that human intelligence, including AI, which is part of our intelligence, is based on millennia of concurrent parallel search. So we deploy those heuristics, and that's how we're so smart, because it's hard to be smart, okay? Right, so this is also where implicit biases come from, okay? Now this is something we showed in 2017. I'm sorry, it's a little bit old news, but I feel like this was understood and it's gotten forgotten again, all right? So people sort of know that bias in AI comes from the data, but they've sort of forgotten that the reason it's in the data about the world is not just because the world is evil, but because this is a natural outcome of how we understand things. So the original paper was about implicit biases, like thinking that women are more likely to be associated with family and domestic sphere, and men are more likely to be associated with career relative to each other. So that was a discovery in psychology that we showed was absolutely replicated in the word embeddings, which are basically the AI representations of the meaning of words that we use when we do things like translate or web search. Okay, so, but the thing is, we didn't just show that AI replicated the biases. It also, now that we could measure the biases, we could check where they came from. And it turns out that these same horrible sexist word embeddings, that's on the y-axis there, are really well correlated with what proportion of, for example, this is about, these are the dots represent the names of jobs in the US labor market, and the US kind of dominates the English language internet, sorry about that. So anyway, you get a 90% correlation between the word embeddings, which are matching human implicit biases, and also the actual proportion of women who are in the jobs, okay? So what that tells us is that we're replicating the implicit biases, and the AI are showing us our own lived experience, okay? Our implicit behavior isn't our ideal, it's our experience, it's our history, right? Consciousness, explicit, that's the difference between implicit and explicit. Conscious choices are how we get to something better. All right. So yeah, robots are not going to magically fix this for us. We're still working the same way. And I feel that I'm going a little slow, but I just want to point out, when you have something that you've designed and owned, it's not going to be your friend, right? You can't have a consensual relationship with something that's owned. And that was horrifying to me when I came into ethics and started finding out that there was no way to have consensual sex between a slave and an owner. I thought, isn't that taking away the agency of the slave? But the point is, it's acknowledging that agency had already been removed. All right. So, and also these robots that the BBC unfortunately has suggested perhaps could take care of the elderly, they can't even throw a dice. I have one of these. We're doing an experiment with AXA Research, and we had to make a paper die for it to throw, for throwing die. I don't want to go into too much detail. Cool research on AI transparency. Anyway, a robot is not a friend, it's not a peer, it's not something that's going to magically solve problems for you. It's rather an extension of a corporation with cameras and microphones that you have in your house. So that's a better way to think about it. So safety is like bias, because we need to ensure that products are safe, including that they observe social justice. And we cannot ensure that algorithmically, or at least like automatically within the computer itself. We know for certain that mistakes are going to be made. And so therefore, we need to be because we know mistakes will sometimes be made, we can also be certain that corporations will try to evade their responsibility for things like doing due diligence, or they may even do something totally evil. They may be trying to money launder or something. And it's important that we don't allow people to think that, oh, it's AI, so it's opaque, we can't do anything. And that's something I'm very critical of. There's no reason that the EU white paper repeats over and over that AI is opaque. All right. We have to hold the human developers and operators to account, and that's the next topic. How do we ensure AI prosociality? We don't regulate the micro detail of how the AI works any more than we regulate like how you use your synapses in your brain. Instead, we look at how the humans behave when we build, train, test, deploy, and monitor AI to make sure it's working correctly. All right. So a good maintainable software system, when you do the systems engineering for that, which is an engineering discipline that predates AI, but in fact, it predates software, but has been used in ICT since the early 20th century. We architect the system, we design it, we sit down and do that. We know what the components are and we know how they're connected, and we decide how to make sure that they're maintained. We check and see who wrote the code. Where did we get the software libraries? Where did we get the data? If we use data to train machine learning to build the code, right? So all of these are things that we can keep track of. We can keep track of, I just actually mentioned that, sorry about that, a little redundancy. We can also keep track of the system as it runs, right? And that's why every time there's been a fatality involving a driverless car, we've known what the system thought, right? We've seen what it saw, and we knew how it was categorized on the front page of the papers within a couple of days, right? That is perfectly doable. The automotive industry is regulated well enough that they do it. We need to make sure that some of the newer sectors are equally well regulated. If we get this wrong, we tend to get entropy. And so this is actually about my most recent paper that came out in December, but this is not my research. This is the older research on which my paper was built. We know that political polarization and other kinds of entropy are highly correlated with wealth inequality, all right? So if you don't adequately govern the organizations or sectors, then you get regulatory capture, and that tends to lead to inequality because they tend to favor themselves, all right? And then when you have high inequality, you get social unrest, you get loss of social mobility, that leads to a decline in innovation, and you get insecurity, all right? Even the problems like the housing crisis, you can understand in terms of the fact that some people have so much more money than other people that they live at a vastly different housing density, right? So these are fundamental questions about social justice. This is the model that I just mentioned and that just came out in December. I just want to point out, so the idea is that we know diversity gives us more strength, but we also know that it's scary, right? It introduces things we didn't understand. So even what we showed mathematically with this model was that even in a situation where you know the better outcome is going to be with working with the out group, the diverse group, you might choose to work with the in group when you're in a situation of threat. And where does that threat come from? It comes from an economy that's declining and the fear of things like bankruptcy, foreclosure, divorce, really large losses that basically make your life a lot worse, okay? So those kinds of things happen under an inequality if we allow inequality to create false scarcities. All right, so how do we ensure prosociality? We have to enforce the regulations that guarantee safe commercial products, and we also need to ensure antitrust is enforced and favors democratic governance. That was what the antitrust laws were invented for. They've been co-opted to only fixate on consumer prices. And we all know from Lena Khan that gives us basically Amazon, the optimal squashing of consumer prices, but not necessarily the drop in inequality that we need to be safe. So I've promised to give you these points, and I have. Thanks for your attention.
Thank you, Joanna, so much. That was fascinating. Lots of things to talk about there, but please hold on to those thoughts. We can put them in the Q&A. And next up, we have Nathan Lepora, Professor of Robotics and AI at the University of Bristol, and he's going to say a few words and I think give us a demo. Okay, so I think we're just waiting for Nathan to set up. Again, please take a look at, go to Slido, and if you have questions for Joanna or for Nathan, please post them there, or you can upvote other questions that are already there, and we'll get to those right at the end of Nathan's talk in just about 8 or 9 minutes. Nathan?
Okay, thank you. Hello. So today I'm going to talk about AI for robot dexterity, or perhaps a bit provocatively, AI people don't care much about robotics, but they should. Why do I say that? Well, I think there's a tendency in the AI community and in AI organizations to put pictures of robots on the front of reports and documents, but not to really engage with roboticists and robotics and kind of take it seriously what AI is doing to robotics. For example, there's not usually much AI, much robotics at AI conferences such as this one. So I'm really, really grateful to be here. And I think ethics is a really, really important problem in AI. But I'm sure many people have noticed the robotics that I do is a bit different from the other things that are being talked about. Okay, so to kind of state the obvious here, AI runs on computers. Computers affect the world by communicating with humans, and then we affect the world around us then from the knowledge we've gained. Now, robotics enables AI to directly affect the world we live in. So it can involve humans, but it doesn't need to involve humans. So it's a broader paradigm for how AI can affect the world. And I think the robotics will become increasingly important for AI going into the future. So the robots are here, but if you like, more are coming. So I don't think it's widely appreciated. There has been an AI revolution in robotics, in robot vision. We have driverless cars on our roads driving around. So that would have seemed like science fiction just 20 years ago, but it's reality. And driverless cars are visually guided robots, and similar technologies in visually guided drones and in industry. So that's mature technology. It's on our roads, it's in our lives. Now the new revolution in robotics, which AI is causing, is the revolution in robot dexterity. So, which is just starting. And so if you like, the aim of robotics since its inception was to interact physically with the world and do work. That's where the word robot comes from. And that is the revolution that is just starting to take place, but is accelerating at an enormously rapid rate because of AI. And so that has applications to, for example, logistics, healthcare. Here's a picture of Jeff Bezos having a fantastic time on a haptic robot teleoperations system. So when I look at this, I like to think he's saying, yes, now I see how Amazon can take over the world using this technology. You know, something for you to think about, the impacts of robotics in corporations. Demonstrations. I'm going to give some simple idealized demos of robot dexterity that indicate where AI has taken this field. All demos were first done last year from a smallish group, mine, with modest funding in an area with big players such as Amazon, Google, MIT, and so on. So I'm very proud of the institution that I'm at, Bristol, in the West Country, but I'm not going to pretend to you that we have the capabilities or the resources of these big players, clearly. Okay, so on to the demo. So this is the first one. So this is AI enabling a tactile robot, a robot to use its sense of touch to feel over this complex object. So here, this task has only been done last year or so. It's using AI to feel the object and to guide the robot's movements, a convolutional neural network. This is not possible unless you're using the recent advances in AI. I can't see any reason, any way to do this if you weren't using the convolutional neural network. And the thing is, once that works, the AI is really good at generalizing to situations that are a bit different from what it's been taught on. So this was taught on, if you like, a flat surface, but then works in a variety of different situations. Still idealized, but it's shown the capabilities here that once it's been taught how to do this kind of task, it then works in a much broader situation, as robust to feeling many other things. Okay, moving forward. So the same algorithm, now instead of feeling the object, is pushing objects around. So the robot kind of knows in joint space, proprioception space, where it wants to where it wants to push the object to. It doesn't know anything about what the object is or the shape of it. It's just using its sense of touch to push the object to that goal location. And I say it's very robust. The same algorithm just works on basically whichever object you give it. So now moving on to robot hands. So this is same tactile technology embedded, integrated into a robot hand. So this is a very good robot hand. It won the DARPA Grand Challenge about 7-8 years ago. It was open sourced. We built it ourselves in the lab and integrated our sensor with it. So here it's using the sense of touch to recognize the object when it picks up and to recognize if a grasp will fail before it lifts it. So here, say it predicted it was going to picked up that cube in a different way and predicted it was going to fail. So the tricky thing here is that it's able to do this without knowing how it's holding the object. Just trained that, you know, the grasp is slightly different in some circumstances, and it just figures out that it'll drop the object. So here's another example. So catching objects. So if you have a sense of, for hands, picking up objects up is really important, but then not dropping them once you're holding them is also crucially important. And this is showing the same technology. It doesn't always work, but works most of the time. This is showing the same technology. It relaxes the grip and then is able to detect the object's going to fall and then recatches it. Works in the hand. And here's a case where it's adding weight to an object and it slips and then it catches it. Okay, and then this is a bit more limited, but this is kind of indicating where we're going. So these are more dexterous robot hands. One is an anthropomorphic hand like ours. The other is an fully actuated robot hand. These are quite limited demo, but this is we're moving forward onto this into more dexterous in-hand manipulation tasks. So how did we do this? So we used convolutional neural network for perceptual system, trained robustness into that network for using some tricks, a bit like image augmentation, and then we combined with conventional feedback control for robotics. So another way, a more powerful way, is rather than, if you like, predicting the state, predicting like the pose or the force of how you're holding it, conventional robotics, you instead just directly control the robot with. So you choose the actions using a policy network, and then you can use deep reinforcement learning to learn a skill for how the robot interacts with the world. and so you're punishing and rewarding if you've done the task properly or not. So here's when we first got this working. So this is kind of the first in the field. So it's a bit of an artificial task, learning to type on the Braille keyboard. Took a couple of days for the algorithm to learn, but then it could learn where the keys are, the keys that it wants to press, and how to navigate from one key to another across the keyboard, just using a sense of touch. So we chose this task partly because it would be hard for a human to learn how to type on the Braille keyboard. And we wanted to show that, you know, to have a task that's not so immediately obvious how to do. So but the robot learned it.
Nate, that's fantastic, Nathan. Can we? Well, sorry, we'll have to just end here for the moment to give time for some questions. That was fantastic. I loved ending on that real hello world moment. That was brilliant.
Okay, that's fine. Fair enough.
Thank you. And perfect examples of real world safe implementation of systems. It was brilliant. Thank you. So we're going to have time for just a few questions. Please do post in Q&A, and you can get in touch with our speakers afterwards. I'm going to just open up with one specific question, going back to something Joanna mentioned. I thought it was sobering to recognize that the reasons that AI systems often can be biased is because they're built on past human bias, but in fact, that just is the way it is. And in fact, I do see it as optimistic, which I think is how you see it, because it shows how maybe we can try to do something better. But then I was just wondering about your slide where you said safety is like bias, because it seems to me that perhaps bias is different from safety in that it's subjective. So how can we try to ensure that we really engage people properly to address that effectively?
Okay, well, first of all, I want to say, Nathan, that was beautiful work, and I only wish Bath and Bristol Robotics Lab were closer together, so I could have spent more time there. That was great. Secondly, but going back to Nathan will confirm this. When you talk to AI people, machine learning people about bias itself isn't the problem. The way we use the word, that's just a regularity. So the whole point is that when you're trying to do learning, you're trying to find those regularities so you can reproduce that great behavior. So the vast majority of what is being learned in word embeddings is really how the language works. That's why you can use search engines. That's why we can do translation, right? But some of those things about the way that the language works are things we don't like now. I mean, we used to like it. There are people alive now who like it. There are recent former presidents of the United States that think that's a great way for the world to be, right? But the point is that we've come to a consensus that we think that those things are not the way we want the future to be. So we call them stereotypes and we call them prejudices, and we're horrified by them. But again, it turns out it was our ignorance that we didn't even know that what these terrible stereotypes were a part of the biases, the actual situation in the world. So the similarity, the way, maybe I didn't make that clear enough. The similarity is we will have these gaps. We will have things that will go wrong. I've been in rooms with, you know, professors of philosophy that you would think would know better, that say there's no excuse anymore for a corporation or a government ever to make a mistake because we have AI. And that's just not the way the world works. Safety requires governance. It requires an enormous system, both to attempt to get things right the first time and to use all the collected wisdom we have, but also to recognize things that have gone wrong and to recognize and correct. And that's why we have governments. That's also why we have self-governance of corporations and of governments. And that's also why we have civil society to protect us when both governments and corporations go wrong, right? All of this is a complicated network of catching mistakes. So the point is that we cannot do everything proactively. We need to be able to recognize that there are always going to be limits to our intelligence. We will never be omniscient. And so we always have to build systems that are cognizant of that and that capture the mistakes.
Thank you. Super important point. And also thank you so much in your talk for establishing or recognizing that link between good governance and trying to avoid inequality and subsequent social unrest. Really interesting work. I'm going to turn to try to address maybe the top two questions which have come up in Slido, and perhaps these I might first turn to Tabitha to address these. I think that you might be able to do it fairly quickly, particularly the first one. So the first one says 4 pillars don't seem to mention responsible ethical or AI innovation. Is this something that's been considered at all? And I think you're going to say, of course, it's really central, but I'll let you answer that. And then also, what is the USP for the UK in the area of AI and data science?
So you're right. Every time we use the word AI in the roadmap, we mean safe and ethical AI. We just don't use it every single time we use the word. Rather than it being one of the pillars, it's fundamental to the whole recommendations. In terms of the USP, now that is really the billion-dollar question, and what we are doing the next 6 to 9 months work on is trying to gather more and more information about what already came out of the last government intervention here, the £1 billion sector deal, what needs to be doubled down on, which is a USP, and what people feel. And I hate to sort of lead the witness, you know, ultimately we're looking for the community to draw on what the USP is. But I think this session itself on safe and ethical AI shows that that is where our USP is. And the conversation I have internationally, I'm part of the GPA, which I know Joanna is also, all those conversations, people do look to the UK for leadership in this area, and we should be really conscious, proud, and really welcoming to that conversation, and not boastful, but definitely know it's a USP.
Absolutely, yeah, we want to work collaboratively with our friends and partners. An important message. I'm going to go to a question from Alexander Mikhailev. Should we have a joined framework for both human-based decision-making and AI? At the moment, it looks like AI maybe has to fulfill more requirements than humans. This is an interesting question. Who wants to take this?
I'm happy to take that, if that's okay. So to some extent, yes, my first thought is we should be joint in that that we need to recognize that artificial intelligence is an extension of human intelligence. So differentiating sometimes doesn't make sense. On the other hand, as soon as you get that extra level of deliberation that programming a system takes, then the standards should be higher. And if you're trying to say, well, is that fair? What's going on? Think about all the hurdles you have to jump through if you want to adopt children. It's a lot different from the hurdles you jump through to have children, conceive children otherwise. So the reason is because now the state is involved. Well, there's some difference in risk, but also the state is involved, and so the standards have to be higher. And so a lot of people, for example, who are disabled, really don't want to wait until driverless cars are 10 times better than ordinary drivers at being safe. But it's quite likely that we will need that kind of security, partly just because of the difference in liability considerations, because it's not the driver anymore. And partly, of course, because the mistakes that we will make with AI will be quite different from the mistakes human drivers make. So the human driver is still on the road needs something that's way more predictable than human drivers actually are. So it's essential that we accommodate humans. That's why the OECD was right to make that the first principle, that we must be human-centered and we have to accommodate a human understanding.
Thank you, Joanna. It feels like we could probably discuss just that topic for a good long time. I think we might officially be out of time. I'm going to keep going until we get cut off. I'm going to try and push to see if we have 30 seconds, maybe turn to Nathan and say, do you have any thoughts on how we can maybe have robots and humans work together, and any particular issues to think about there?
I think so. A lot of people tend to concentrate on the social aspects of how humans and robots should work together. But I think a more fundamental aspect is the physicality of the interaction. That's the harder problem to solve, and what robots are quite poor at the moment. And I think maybe an appreciation of the physical human robot interaction as well as the social human robot interaction.
That's a great point. We'll end on appreciation of our human physicality. Beautiful. Thanks so much everyone for joining us, and thank you particularly to our wonderful speakers, to Tabitha, Joanna, and Nathan.